Good morning, guys. So today we're just going to take a look at the examples that they went over in the video. So I'm assuming you guys saw the notes video for 2.4. And what I want to do is just go over the examples he went over, but using the website that we've been using, which is the Staplet.com, and show you guys how to get the same answers, but without a calculator, right? Because we don't have, or where you guys are, you don't have, you may not have access to the TI Nspire and things like that. But I do want you to be familiar with the Staplet website because it does kind of the same job, right? So in this first example, it says you take an IQ test and you score 124. And so using the website, and so let me pull up a browser. Okay, so here we have the Staplet website, and we're going to click on normal distributions. The mean is 100, standard deviation is 15. Plots it. Okay, so in this problem, they wanted us to find the percentile. And so the percentile, again, means anything below a particular value. So we want to shade this area below the score of 124. And they were pointing out that 124 is not a key tick mark, right? It's in between two tick marks. So using the Staplet website, we want to change the calculation to find it to the left of a value. And that value of interest is 124. So calculate the area. It's 94.5%. So what percentile? The 94.5th percentile. And that should match the same answer that Mr. Young-Saver got on his calculations too. And it shades it also, right? It shades everything below. I just shaded it in red. The program shades in blue. And so we got 94.5, which is the same, the same percentage that Mr. Young-Saver got. So I would say a score of 124 is at the 94.5th percentile. Right. So, and again, feel free to pause the video at any time. Let's look at the next question, part B. And so part B was asking, what score would you need to earn to be below 88% of the test takers? So that means we're interested in 0.12, right? Because we want to be low. We want to be below. And so if I shade the right side in blue, let's say, then we're saying that in this blue area is 0.88. And so everything below is 12%. But the nice thing about the Staplet app is that you can use either percentage depending on what settings you put. Okay, so let's check it out. Let me zoom in here. So we're going to do same plot, but we're going to calculate a value that corresponds to a percentage, right? What score would you need to be below 88%? So we're going to use the same distribution. And do we want to, here in this calculation part, do we want to calculate, do we want to calculate to the left, or the other option is to the right? So this is the nice thing about the Statplet app. You can choose what side you want to find. So let's say we choose the left. So then we're going to look at it, looking at point 12. And then calculate, right? And so that gives us 82.3, but round to the nearest whole number. You need to get an 82 on the IQ test to get below 88%. Okay, so that's shading the bottom left side. But how much area should be over here? If down here is 12%, then up here in this white area should be 88%. So let's try it the other way around. Let's change the calculation to a right tail, and let's change the percentage to 88 and calculate. Well, we get the same answer, 82. It's just saying, you know, what value on the x-axis would give me 88% shaded on the right side. Or you can ask, what location on the x-axis would shade 12% on the left? This white area is 12. So you can ask either way, but you have to pay attention to the question, right? Does the question say below or above? And that can kind of tell you what you're going to use. Are you going to use a right or a left tail? And so our answer here would be you would need to get in 82 to be below 88% of test takers. Okay. Again, feel free to pause. Let's go to the next page. And here he kind of talks about key points and kind of things to think about. If they say words like percentile, think of below. At least means anything above a certain point. Areas are usually calculated below, but that's for the TI Inspires. But for the Statplet app, the Statplet website, you can choose which direction you want to go. Okay. The other problem that was one of the examples here is the question being, what score would you need to get to qualify for the Mensa International? And Mensa International only accepts people that are in the top 2%. But I want to know, what should be my score? What should be my value on the x-axis? So again, let me pull up browser, statplet.com, go to normal, 115, plot it. And so I want to be in the top 2%. So I'm going to calculate the value corresponding to an area. And again, area here is representing percentages. So I want to find an area. I want to find a percent. I want to find a location on the x-axis that represents the top 2%. So let's calculate it, looking at it, shading from to the right, towards the right. Since we're talking about top, we're looking at the top percentage, top 2%. So I'm going to put 2% as a decimal, would be 0.02. Calculate. And we get the following. We should get a 130.8. And I believe that's the same answer that he got on his calculator, right? So that's what I mainly wanted to show you about the normal distribution. And again, you can go the other way around, right? We can say change the right tail to a left tail and change point 0.02 to 98. And we should get the same answer. So keep in mind what answer is there, right? 130.8. And let's calculate 130.8 again. But it depends what you want to shade. Both answers both methods give you the same answer. So it's up to you how you want to analyze the problem. And so here you would say, you need to score 130.8. So your score would need to be 130.8 to be in the top 10%. The other question, he's saying if there's 328 million people in the U.S., how many are geniuses? We're thinking about people who are in the top 2%. And so if you do this calculation, we get about 6.5 million. I want to skip over the discussion because I know you guys are going to submit it in the survey. And plus, if you're watching this video, I'm not there with you to discuss it, so I like to have input from you guys. So we're going to skip the discussion part and go on to the activity. Okay, so we're going to keep practicing, and these first couple of problems that we're going to look at deal with, we can still use the empirical rule. So we're kind of reviewing the empirical rule. But let's read the scenario, right? It says, after accelerating for 20 seconds, a DeLorean sports car has a wide range of speeds that it can achieve depending on traction. The distribution of speed follows an approximately normal distribution with a mean of 80 miles per hour and a standard deviation of 7.7 miles per hour. Okay. Label the appropriate values on the normal distribution. Nice. So here they drew it for us. And so we know by the given information that the mean is 80. So I'm going to put 80 right here, 80 miles per hour. And it has a standard deviation of 7.7. So if I subtract 7.7, I get 72.3. If I subtract 7.7 again, I get 64.6. If I subtract 7.7 again, I get 56.9. And then going up, if I add 7.7, I get 87.7. I add again, get 95.4. And then I add one more time. That gives me 103.1. Okay, and the first question is, what percentage of the runs will give the DeLorean a speed greater than 87.7 miles per hour? Greater than 87.7 miles per hour. Well, what we're looking at is from here, and it says greater than, so we're going to shade everything above. But the nice thing about 87.7 is that it's one standard deviation above. So this is kind of similar to the overflowing cup problem with one standard deviation above. So if I know that at 80 miles per hour, if I shade from this point and everything below, it's 50%. And then how much is here? It's 34%. So this whole area here is composed of 50% plus 34%, which is 84%, right? So that means that this area in blue is 16%. So we don't need to use the Staplet app. We can just use the empirical rule here. Okay, so we would say 50% plus 34% is 84%. So we would say that 16% of the runs would achieve 87.7 miles per hour or greater. Zoom out here. Okay. So I'm going to go ahead and erase the red and the blue, but I'll keep the purple values there. Okay. Okay. What else? Next question. Move this up a little bit. Next question. What percentage of the runs will give the DeLorean a speed between 64.6 and 87.7? 64.6 and 87.7. Okay, so here, this one might be a little bit different, where we have to, so I'm going to say, between 64.6, so it's between here and 87.7, which would be here. So we're looking at shading this percentage. This area. So you should notice that, for example, this area in blue here is 68%. So we got a good majority there. So we know it's a little bit more than 68%, but since it's between two values, let's go ahead and use the Staplet app. So I'm going to pull it out. It's browser, Staplet. Keep misspelling it. All right, so the mean speed was 80 miles per hour. The standard deviation was 7.7. Plot the distributions, same one that we have. And we want to know the area. What's the area under the curve? So I'm okay with this calculation or operation. And we want to know between two values. So this is good also. So between which two values again? It's between, right there we have 64.6 and 87.7. 64.6 and 87.7. Calculate the area. We got 81.86. Okay. So 81.86% of runs would achieve a speed between 64.6 miles per hour and 87.7 miles per hour. But I'm going to put this in the background over here. All right, next question. What percent? Oh, I forgot almost to erase this. Right, so we have to erase this really quick. What percent of the runs will give the DeLorean a speed less than 64.6? Less than 64.6. Let me use a different color here. Less than 64.6. So for this one, we know that two standard deviations away. Let's say we know that from. Oh, sorry. Let me change the color. Not the color, but the pencil type. We know that this area here is 95%. And so the total area of the whole curve should be 100%. So that means the part that's not enclosed in the green adds up to 5%. But what's half of 5%? 2.5%. So that means that this area here is 2.5%. Because this other tail over here, this white area, is also 2.5, right? Because 2.5 plus 2.5 is 5%, and then plus another 95% is 100%. So here we would say, what percentage of the runs will give the DeLorean a speed of less than 60? So we would say 2.5%. What percent of the runs will give the DeLorean a speed of less than 68.45? Okay, and so now we don't have the luxury of using the empirical rules, so I'm going to go ahead and use the Staplet again. And so let me just move this up over here, and then I'll zoom in over here. So we want less than 68.45. So I'm going to change my calculation to the left because I want less than 68.45. Calculate. Right, so I got 6.68%. 6.68%. Right, so for homework, I'll stop the video there, just so that it's not too long of a video, but you guys kind of get the gist of how to use the Staplet app. So for homework, if you guys can work on number 6, 7, and 8 on the next page, and then on check your understanding on the last page, problem or questions 1 and 2. All right, and so thank you for joining me today. I hope that you guys were able to understand how to use the Stamplet app, and the purpose of today's lesson, was to figure out how do we find the percentages that are in between standard deviations, in between whole steps, that they're not necessarily tick marks, like here, they're not exact locations on the x-axis, they're in between standard deviations. And so knowing that it is possible, right, because the last lesson we said, it's not possible to find the percentages for exact locations if it's not in the empirical rule, but there is ways, as we saw today. So thank you again for joining me, and I'll see you next class.